Day 27, Ionic Compounds with Polyatomic Ions, Part 2. So today we're going to put the compounds together using polyatomic ions with a -2 charge and -3. By now I'm hoping you've had plenty of time to memorize that list of periodic tables. You should have a pretty good memorization of all of the periodic table of ions. So what I'm hoping is that these are going much faster for you. Now let's get started. Alright. The first thing we're going to do is we're going to mix sodium with a sulfate, and we'll remember that sodium is a +1 ion and sulfate is a -2 ion. Sulfate is SO4. Sulfate is SO4. We had to know that. Since sulfate has a -2 charge and sodium has a +1 charge, I'm going to need 2 of the sodiums to mix with the sulfate. So I have Na+1, Na+1, and SO4 -2. So let's write this out. I have sodium with a +1, and I have sulfate, SO4. This whole thing has a -2 charge. So what I'm going to do is put parentheses around it. -2 charge. Okay, so I have to get to 0. I have a +1 and a -2. I have to get to 0. That means I need another one of these sodiums, and that's a +1. Now the only thing that I did differently here was I included some parentheses because I wanted to treat this sulfate ion as a complete unit. This whole thing, SO4, has a -2 charge. That's why I used the parentheses. So sulfate is a -2. Each of the sodiums is a +1. So now we get +1 + 1 -2 equals 0. And so now we can write out our formula. How many sodiums do we have? We have 2 of them. How many sulfates do we have? SO4. How many do we have? We have 1 of them. Notice that this 1, since we only have 1, we do not write the parentheses, and so we'll say Na2SO4, just like we have here. Sodium sulfate. And you might say, well, wait a minute. What about my crisscross? How does that work? Sodium is a +1, sulfate, SO4, that's a -2. Notice that I used the parentheses again, and we just play that crisscross game. We'll get Na2, parentheses, SO4, bring down that 1. Now, since there's only one of these things in parentheses, we ignore the parentheses, Na2SO4, and we get the same thing. Great! That's how it's supposed to be. Easy. But what if you were wanting to name this? What if you were given this first and were told to name this? How would you name it? The easiest thing to do, since you have that list of polyatomic ions memorized, is to look out when elements are grouped together like this. You want to be on the lookout when you see a combination that looks like it could be a polyatomic ion, such as this, SO4. Then you'd go through and say, well, what's in front of it? Oh, sodium. Hey, sodium is in front of this polyatomic ion. Sodium forms +1 ions. Sulfate forms -2 ions. Sodium, sulfate. So you need to be able to break it up. Sodium, sulfate. What if you forgot what the charge was for sulfate? Well, that's when you write it out again. Na2SO4. Sodium is a +1 charge. Sodium is a +1 charge. +1 times 2, that's a +2. A +2 plus something has to equal 0. What does this something have to be? A -2. And what do we have here? We have 1 of those sulfates. So something times 1 is a -2. And that something is a -2. So we're still trying to get to 0. So let's try another one. Sodium, again, let's work with it, but now instead of sulfate, let's work with SO3, sulfite. Notice that it looks real similar, but the difference is just one less oxygen. Sulfate, sulfite, SO4, SO3. Well, sulfite has a -2 charge, and sodium has a +1 charge, so I need 2 of the sodiums and 1 of the sulfites. Na2SO3, sodium sulfite. So instead of me choosing sodium, I'll choose potassium because it also has a +1 charge. Or I'll choose lithium or silver. And instead of me choosing sulfate and sulfite, so what I'll do is I'll go to that polyatomic ion sheet and just pick a different polyatomic ion that has a -2 charge, like carbonate, peroxide, or chromate. And then I just shove them together. Pick any of the +1s, pick any of the -2s, shove them together. +1 + 1 -2 equals 0. So then we get potassium carbonate, lithium peroxide, and silver chromate. What if I asked you to write out the formula for lithium dichromate? So the first thing you'd say is, hey, lithium, I know what that is, Li with a +1 charge. And then you'd have to go and say, okay, no, dichromate. Dichromate is Cr2O7, and this whole thing has a -2 charge. So what possible methods can we use for finding out the chemical formula? Well, we can go back and use what we first did with +1 + 1 -2 is 0. And so we'd say, oh, we have a -2 and a +1. We need another one of these +1s, Li +1. So we're going to have 2 of the lithiums, and then we have 1 of these dichromates, Cr2O7. We have 1 of those, 2 of the lithiums, and 1 of the dichromates. But since there's only 1 of these dichromates, we do not include the parentheses. So what we do is we write it as Li2, Cr2O7, lithium dichromate. And that's how it's done. I'm hoping that you picked up on knowing that the more polyatomic ions you know, the easier it is to name the chemical compounds. And the next set starts with sodium phosphate. Well, again, I picked sodium, and now I had to pick phosphate. And phosphate, if you didn't know what phosphate was, the polyatomic ion, it makes it really difficult to name. So now I want to write out the chemical formula for sodium phosphate. So sodium is a +1, and phosphate, PO4. Now this whole thing has a charge of -3. So I want to get to 0, so what do? Well, sodium +1, right? I need 3 of them. +1 + 1 + 1 -3, I get 0. Write out the formula, Na3, parentheses, PO4, and I have 1 of those. And since I only have 1 of them, we drop off the parentheses, and so I get Na3PO4. Otherwise, what I could do is I'd say sodium, Na with a +1 charge, and phosphate, I know phosphate, PO4, that's a -3 charge. I play that crisscross game, and then I get Na3, parentheses, PO4, 1. And then again, I drop off the parentheses, Na3PO4. So what if we had Na3PO4 and I wanted to know the charge of this phosphate ion? Let's say I forgot that it was -3. Well, the first thing you do is you'd say, well, hey, on that periodic table of ions, sodium is a +1, and sodium is a +1. Okay, good. +1 times 3, that's a +3. +3 plus some number has to give me 0. That number is a -3. I have 1 of those phosphates. So some number times 1 gives me a -3. Phosphate has a -3 charge. There, wasn't that fun? So sodium is a +1, borate -3. So I'm going to need 3 of the sodiums and 1 of the borates. Sodium borate, Na3BO3. Now all I'm doing is going down that list of +1s in the periodic table of ions and choosing a different +1. So instead of sodium, I choose potassium, lithium, or silver. I just grab another one of those +1s. I'm just mixing those ions with the polyatomic ion that has a charge of -3. And since the polyatomic ion has a charge of -3, I'm going to need 3 of the +1s. So let's look at this one right here. Silver phosphate. Silver, Ag, that's a +1 charge. Phosphate, PO4, that's a -3 charge. Phosphate, -3 charge. I want to get to 0. What do? I'm going to need 3 of these silver ions. 3 of these silver Ag +1 ions. +1 +1 +1 minus 3 equals 0. My formula is going to be Ag3, PO4. PO4 is in parentheses here. There's 1 of them. So my formula is going to be Ag3PO4. Exactly like we got there. Now I want you to notice that when I say use any of the +1s, I'm talking about right now where there's only 1 in the box. Remember on that periodic table of ions? We want to look for +1 ions where there's only 1 in the box. Now we could pick other ones that were more than 1 in the box. The reason why I'm doing that is because I want to separate using those Roman numerals. I mean, we don't have to. Sure, if I asked you to write out what, say, copper 1 phosphate is, copper 1 phosphate. Let's just use one where there isn't 1 in the box. Let's use it where there's more than 1 in the box. Since today we're working with the +1 ions, I'm just going to pick copper 1. Copper 1 phosphate. Well, copper 1 is Cu with a +1, and phosphate is PO4, and that has a -3 charge. So how am I going to write out the chemical formula for copper 1 phosphate? I'm going to need 2 more of these copper 1s, 2 more of those copper 1 ions. And so that's going to give me Cu, and I have 3 of them, and then I have PO4, I have 1 of those phosphates, Cu3PO4 when I get rid of that parentheses. So what I'm doing is I'm just using the ones where there's 1 in the box. I did this example of where there's more than 1 in the box just to show you. But we can leave that for a different day. Well, again, it's time to get your homework started, and if you have questions, let me know. Have a great day.